Good morning to all of you. So this is I think the second last class we are having for online, and today we are going to see vectors. And before starting vectors, as usual we are going to remove the extra insects or pests who are busy in unnecessary chatting. Okay, yes, Sonika Shivani, I am that type of sir who comes late and takes extra time. I am very happy with that. So we are starting to spray pesticides now. So all those unwanted chats are going to be deleted, and such students who are not interested in studies, they are going to be removed. So good morning to rest of the students who are sincerely listening to the classes instead of crying or cribbing for unnecessary things. So let's start. Good morning once again. So here, as I said, we are going to start vectors. I am fine. So we are going to start. Okay. So the online warriors suddenly disappeared who were crying and cribbing. Sir did not start the class. Sir will start late. He will end by taking extra time. Online warriors. Feeling very sorry that you have to draw back your sword. So coming to vectors. Now we have been seeing velocity, displacement, all these are vector quantities, and vector quantities, how do we differentiate them? Acha, I think one or two insects are left still. I did not see your chat and all these things. So kindly remove them. Okay. Sir, what about integration and differentiation? Yesterday I think we were doing integration and differentiation only. Today's topic is vectors written on the board. So now we are seeing the basics of vectors. So I think you all should have observed that these online classes were actually a bridge type of concept which will help you to understand the concepts of physics in detail, that it is not the end of the world, that okay, this is over. It's not so. When you all will have your actual classes, there again you will be dealing with calculus, use of calculus in physics. So this is not that okay, chapter is over, now go home, directly write NEET 2027 or 2028. It is not so na. So that's why whatever has been done, so these all things you have to study, and you will see these are again being used when you start your actual course. So right now, today also, it is not that today and tomorrow vectors will be entirely completed. These are the introduction part which you should know, which you should be aware, right? So now leave the rest on us, that is the teachers. It is the teachers to decide what is to teach, what not to teach. Okay, they are capable of knowing what the students need, and when you will be studying these chapters again, you will feel confident that yes, we know at least something. So when you will be facing questions, you will be able to understand them quickly, or much more quicker compared to students who have not studied them earlier. So coming now to vectors, what all things we should know about vectors, just the brief part we will see. In vectors, whenever we have a vector quantity, vectors have a fixed direction in space, they have a certain magnitude. So we represent any vector quantity you will see if we consider a vector like this acting between 2 points A and B, so there is this arrow which we call as the head of vector. This will be called the tail or origin of the vector, and suppose we represent this vector quantity as a vector. So when we are representing a vector between 2 points, I think this guy, this, who is this Kanna or whatever, I don't know, these are they have not been properly disciplined by their parents, that's why they don't understand what it means when a teacher is saying that while you are in the class, behave properly. Pause the video. So this being head of a vector, this is tail or origin of a vector. Suppose this is a vector, A vector. Okay, some are hell bent on, they don't wish to make other students study, still it is going on. So it is better, is it possible that we can stop the chat? Can we pause the chat? Pause the chat so that no one can type anything. Close the chat box so that no one can type anything. Now, because at least 5 or 10 sincere students are also there in the class, I don't want them to suffer because of some nonsensical elements who are simply into filling the chat so that we cannot see what students are doing who are actually studying. If they want to respond something we are not able to see, better close the chat room. So here we have head of a vector, tail of a vector, this is the vector A. Now when we say A vector, it is from the point A to the point B. So this vector we are taking from point A to point B. So this A vector is also AB vector. So when you represent any vector quantity between 2 points, suppose you take 2 points in space, you can name them as A and B, then you can say that A vector, since it is from point A to B, we will call A vector as AB vector also. And if you see, a vector has magnitude as well. So when they talk of magnitude of A vector is denoted as mod A vector like this. So when we represent the magnitude of a vector, we will denote it as mod A vector, and it is also, since A vector is also written as AB vector, so it is nothing but the length of the straight line AB. So length of the line AB. So it is the length of the line AB which is called as the magnitude of A vector. So whenever we want to represent a vector between 2 points, the starting point, again telling, is called as the tail, the end point is called as the head. So which is represented by an arrow. The length of the line, straight line joining the two, is called as the magnitude of the vector. Second important thing, when you reverse a vector, since it is a vector quantity, it has a fixed direction. When you reverse a vector, then simply it becomes negative of the previous vector, means simply you put a minus sign. If any vector, suppose I call the vector again as A, is reversed without altering or changing its magnitude, so if you reverse the vector without altering its magnitude, then it is represented as minus A vector. So it will be represented as minus A vector. So if you are taking, suppose this vector you have named as A vector, from where to where? A to B. So then if you take the vector from B to A, you will have minus A vector. So minus A vector, in above figure we can say minus A vector is from where to where? B to A. So we will write it as BA vector. So AB vector and BA vector, they are exactly opposite of each other. So this implies we can also say BA vector is nothing but minus of AB vector. So when you are going from one point to other, if you have any vector, A vector, R vector, B vector, whatever you want to give the name, no problem. Once you have given the name, then if you move exactly opposite without changing the magnitude is same, just you have reversed the direction, then it will become minus of the previous vector. So if A to B is AB vector, B to A will become BA vector. So we can write BA vector is minus of AB vector. Is it clear? I hope this is clear to all of you. Now, once we have this representation, symbol you can see, either you can represent the vector by an arrow over its head like this, or you can use a combination of 2 points to represent the vectors, like A vector can be written as AB vector, BC vector, PQ vector, QR vector, and so on. So either you represent it just by a single letter, or if you are representing the vector between 2 points, then you can write it as a combination of the 2 points collectively, like AB, I have written over here, AB vector. Clear? So what is magnitude, what is direction, here we explain. Next important thing which we come to know is there is something which is called as a unit vector. Now when we have vector quantities and we want to assign a direction to them, suppose I say that there is a force of 5 Newton acting on a body, or the velocity of a body is 2 meter per second. So here I have just mentioned the magnitudes of these vectors. Force is a vector, velocity is a vector. I have told them brief about them earlier also. You all know that very well. So these vectors like force 5 Newton, velocity 2 meter per second, acceleration 2 meter per second square, these are just the magnitudes. But when we want to indicate their direction, so every time instead of using a phrase or a sentence that this vector is acting from here to here, using these all things will make it very cumbersome. It will become very lengthy to express every time in sentences. So to avoid that, what has been done is we use a certain symbol, certain representation by which you can identify the direction. Okay. So these vectors are called as unit vectors, which are simply used to show the direction of any vector quantity. So if their purpose is only to show the direction, they should not interfere with the magnitude of the vector. Listen carefully. These vectors are used just to show the direction. They are simply going to guide the vector where the vector is acting, but they should not interfere with the magnitude. Magnitude of the original vector quantity should remain the same. Now let's think like this, that what should we multiply with some magnitude so that the magnitude does not change. Then you will say that, for example, 5. What should I multiply with 5 that I get 5 only? You will say, sir, the answer is 1. What is to be multiplied with 2 to get 2 only? You will say, sir, 1. So when we don't want to change the magnitude, so we should take something whose magnitude is 1 and its purpose is or job is only to show direction. So that's why it is given the name unit vector. Unit stands for 1. So what is a unit vector? Vector having magnitude equals to 1. What is their role? Used to just show the direction of any vector quantity. So if we have any vector quantity, we have to show their direction. So for that we use these vectors, which are called as unit vectors. Now these unit vectors a unit vector is unitless. Now you may say that, sir, what is the meaning of this? Unit vector is unitless. You are saying unit, you are saying unitless. Unit word here means 1. This unit I am talking about like kg, meter per second, that unit I am talking. So it does not have any unit. So unit vector is unitless. So it is simply multiplied to a vector quantity to indicate the direction of that vector quantity, but it does not have any unit of its own. Its magnitude is 1, that's why it is called unit vector, but it is actually unitless. I will show you by examples also what I am meaning over here. Now since these are special type of vectors, their role is only to show magnitude. How do we represent them? So instead of arrow, we put a cap. So to identify them easily, we instead of putting an arrow, we represent them by cap. So when you see a vector with a cap over it instead of an arrow, you will understand that we are talking of a unit vector. Okay. So when we have a unit vector, how do we define it? So how do we write that? Let's see. all these, as I said, whatever you take, their magnitudes are always how much? 1. Magnitude is always 1. Now there are some special unit vectors, because in the talking about the language of physics, when we want to locate the position of any object, we use directions like x-axis, y-axis, z-axis, which you all are aware of. So when we want to represent directions, we use x-axis, y-axis, z-axis. When we want to denote the position of any object or particle, we use coordinates, x coordinate, y coordinate, z coordinate. So every time writing a cap, b cap, it won't sound good or effective. So instead of that, what the physics people did, they standardized something. They said that we are going to take 3 specific directions which are mutually perpendicular to each other. We will call them as x-axis, y-axis and z-axis. And whenever we are representing any vector quantity along these 3 axes, we will be using 3 important unit vectors which will be accepted worldwide. Again listen, they said that wherever we will talk about 3 different mutually perpendicular directions, we will name them as x-axis, y-axis, z-axis. And whenever we represent a physical quantity which is moving only along x-axis or y-axis or z-axis, we will use specific unit vectors which will be fixed for these 3 axes, and the whole world, wherever physics is being taught, they will accept this. Now these 3 vectors were given names I cap, j cap, k cap. So these are internationally accepted. So what I said is, internationally accepted unit vectors along x-axis, y-axis and z-axis, which are mutually perpendicular, as I said, are I cap, j cap, k cap respectively. Now, while I am writing I cap, j cap, k cap, it is not necessary that you put cap on this. This 3 can also be represented as I vector, j vector, k vector. You will see in some books they use I cap, j cap, k cap. In some books they use I vector, j vector, k vector. And in some books they will just write I, j, k. Now for these 3 we have this reservation. Why? Because these are well known faces. So when someone is well known, they don't need to carry a tag of cap. If you generally want to show a unit vector, you will use cap, right? For example, you are studying in a school. As students, you have to wear an I card or keep an I card so that they can identify you that you are the student of this school. But your school's principal or your class teachers or the most important people of your school, of the organization, they don't need to carry I card because they are known by everyone. Those who are not known, whom we can forget, they are given I cards. So same the case over here. These are very important, or VIPs you can say, because the whole world has accepted them. So when the whole world has accepted them, whole world knows them. So whether they wear a cap or don't wear a cap, it doesn't make any difference. So you can represent them as I cap, j cap, k cap also, or you can represent I vector, j vector, k vector also. So you should not have this doubt that, sir, why are we not using cap, why are we giving arrow, even though they are unit vectors. So only for these 3, last time I am repeating, only for these 3 we have this case given that we can use either cap or arrow, or you can even leave that cap or arrow also, just ijk also. So these are unit vectors. Now as I said, what is the role of a unit vector? Whenever you want to give direction to any physical quantity, you simply attach the unit vector along with it. Simply attach the unit vector along with it. So how we mathematically represent any general unit vector. How we represent a vector quantity in terms of unit vector, let's see now next. Unit vector along any given vector. Suppose first thing I want to see unit vector along any given vector. For example, if we have this vector A, so when I take this thing, this is the magnitude of a vector, let's call it as small a, suppose. So when we have this vector, its magnitude is A. Now when I am saying unit vector, along a vector, I will denote it as A cap. Now what is the magnitude of A cap? Is 1. So A cap is simply denoted as A vector by its magnitude. So when you divide the vector by its magnitude, you will call that as A cap. Understood? Or you can write just as A vector by A. That's it. A vector by A. You can cross check. When you will put, if I ask you what is the magnitude of A cap, what you will do? You will divide both sides by magnitude. Magnitude of A vector is A and by A. A by A is how much? 1. So whenever we represent a unit vector along any specific vector, how to represent it? Just divide the vector by its magnitude. Just divide the vector by its magnitude. Clear? For example, if they say a force of 10 Newton is acting along the line AB from A to B. Suppose they say like this. Represent the force in vector form. Just see what I am trying to say. If they say that there is a force 10 Newton which is acting along the line AB from A to B. So now this whole statement we can simply write as, see what? Force, you will take its magnitude. What is the magnitude? 10 Newton. Which direction it is acting? Along A to B. So I will simply attach the unit vector AB cap. I will simply attach the unit vector AB cap. That's it. So once I write like this, so you will understand that this force is of 10 Newton magnitude because AB cap's magnitude will be 1. So 10 Newton magnitude and its direction is along A to B. If you want to further express it as vector, you can also write it as 10 Newton AB cap can be written as I told, AB vector divided by magnitude of AB vector, which is simply AB. Like this also you can write. So 10 Newton AB cap, or you can write 10 Newton into AB vector by magnitude of AB. That's it. Understood? Now, suppose they give you the magnitude of AB. Suppose AB's magnitude is given as 2. So you will get 10 by 2, that is 5. So you can say 5 AB vector, or it is 5 times of AB vector. But in terms of direction only, you will write 10 Newton AB cap. 10 Newton AB cap. This we are using for any vector quantity. Whenever we want to make a vector quantity look like a vector, we simply attach a unit vector along its direction, and with what we will attach? Its magnitude. Now I told internationally accepted vectors, so based on that also you can say Next example we can take. A car is moving at 2 meter per second along x-axis. So suppose they say that a car is moving at 2 meter per second along x-axis. So you will say its velocity will be v vector is equals to, what is the magnitude 2? You will attach a unit vector along which axis? X-axis. What is the unit vector along x-axis? It is I cap. So you will write 2 I cap or I vector. Now don't say, sir, you said I cap and you are putting I vector. I have formed this habit of using vector, but I said that for I, j, k you can use vector or cap, it doesn't matter. So 2 cap, this is the velocity. If the car was moving along y axis, I will use 2 cap. If it was moving along z axis, I will use 2 cap. Understood? So whenever we have vector quantities and we are just interested in representing it in vector form along with the direction, then we simply attach a unit vector along that direction with the magnitude of the vector. Clear? So this concept of unit vector I hope is clear to you. So these are the briefings that whenever you see later also these things, it should not come to you as a surprise. You will have an idea that yes, we had already seen these all things, we are again going to study these all things in detail, right? Now, what we saw till now, how we represent a vector quantity. What do you mean by the magnitude of a vector? Then we saw what we call as a unit vector. After this, we move to what is called as angle between two vectors. Suppose I represent the angle between two vectors as theta. Now here you have to keep in mind there is a limitation for theta, and how do we take theta? Whenever we have to find the angle between two vectors, mind it, vector, if you don't change its magnitude or direction, it remains unchanged. When they are asking you to find the angle between two vectors, that is theta, you have to remember this limitation. Theta should lie in between 0 degree and 180. Means while finding the angle between two vectors, you are not going to take the reflex angle or the value which is more than 180. You have to take the value which is less than or equal to 180. So between 0 and 180, you are allowed to take the values of theta. This is first rule that you have to remember. Second thing, this angle theta is always taken after producing each vector either forward or backwards till their tails coincide. So whenever we take the angle between two vectors, we always take the angle when their tails are made to coincide. If you already see that the tails are coinciding, no problem, you will directly take it as theta, which should satisfy this range 0 to 180. But if their tails are not coinciding, you have to produce them front or back so that you can get the angle. Examples, if you see, you will understand. First example, if suppose I have A vector, this is B vector. Now if you coincide their tails also, they are in same direction. So I will say theta is how much? 0 degree. You coincide their tails by attaching them together, it will be 0 direction wise. If you see, this is A vector and this is B vector, they are opposite. Now what you have to do, either produce them front or back so that their tails coincide. So you can lift it and place it here. So you can show it like this also. A vector I have shown front side, B vector is back side. Just make their tails meet without changing the direction. Direction should not change. So you can lift it from here and place it here also. You are not changing the direction, you are just lifting and coinciding the tails. Then the angle which is formed here, this will be the angle which is 180 degree. If you see vectors like this, this angle is suppose given as 60 degree. So here you will say already tails are coinciding for both. So theta is how much? 60 degree. No harm in this. But if you see, this is A vector and this is B vector and this angle is given as, or say this angle is given to us as 135 degree. Now if they give like this 135, don't say that theta is 135, no. Well sir, you said that theta can lie between 0 and 180, correct. Theta can lie between 0 and 180, but 135 will not be taken as theta. Why? Because their tails are not coinciding. So what I have to do, I have to either produce B backwards or forward or A backward or forward so that their tails coincide. So if I want to do so, you know very well what is to be done. See here, this diagram I can redraw. This is B, this was given as A. So I can produce A forward also. So just shift A forward, produce it forward. Now you can see their tails are coinciding. A can be produced like this also. So this was given as 135. So this will be taken as theta. I have just produced it forward. Lift it and produced it forward. Theta will become 45 degree. So angle between A vector and B vector in this case is not 135 but 45 degree. Understood? Sometimes it may happen that whatever you are seeing as the angle, that is only the angle between vectors, even though tails are not coinciding. Let's see. If we have, this is A vector and this is B vector, and suppose this angle is given as 37 degree. So here theta will also be 37. Why? Go by our same old rule. We have to make their tails coincide. So how can we coincide the tails? Just see again. This was given A, produce it forward. This is also A. This was B, produce it forward. This is also B. Now you can see if I produce it forward both, you can see their tails are coinciding. So we know in geometry in class 9th, 10th we study angles, vertically opposite angles. If this is 37, so obviously this will be theta. Theta is also 37 degree. So in such cases, even what the angle you are seeing over here by heads coinciding, same is the angle where tails are coinciding. So theta in this case will be 37 degree only. So in these examples, you can see what we are doing. We are simply connecting the tails of the two vectors, and once we connect the tails of the two vectors, the angle which is formed between the vectors satisfying this thing, it cannot lie out of this range because we are bound to obey these rules which are followed worldwide. So we cannot form our own rules. Why are we not taking? You cannot take. If you will take, you will be simply given wrong or you will be proven wrong. So they have asked us to use this rule and worldwide accepted rules. so we follow this. So we cannot change this presently. If you become future scientists and then you think that no, I will bring a revolution, whole world will obey me, then you can change that, but presently you can't. Very sorry for that. So how to take angle between two vectors, I hope this is also clear to everyone. So angle can be 90° also, angle can be acute, obtuse, right? One more example we'll take over here. Suppose we have vectors in a triangle and they give these three. Sum is 180, you can see. And another we have two cases. We have to find the angles between A vector and B vector and C vector, A vector and C vector in both the cases. Now if you see, I start with the first one. So if I see the first one, what I have to do, as I told, first draw the triangle and then make their tails meet. You can see that this is A vector, so I can produce it forward and this will also become A vector. This is B vector. To make the tails meet, I can produce it forward. This is B vector. So this will be the angle between A and B. Now they had given this as 70°. So this angle between A and B, this will become how much? This is 70 only. So this is 70°. Now if you see B and C, to make their tails meet, I have to simply elongate C. This angle was given 60°. So I know this angle is to be taken between their tails, 120. And if you see C and A, already their tails are meeting. So this is how much? 50°. So my answer is theta A vector and B vector is 70°. Theta B vector and C vector is 120°. And theta A vector and C vector is equals to 50°. Okay. Now come to this example. In this example, you can see this is A vector, this is B vector. Their tails are not meeting, so I will produce it forward. If this is 37, so this angle I have to take between A and B. 37, 180 minus 37, how much it will be? It will become 143°. If you see B and C, their tails are also not meeting. So I have to produce B. So you can see B and C, this angle was 53, but tails joining, the angle will become 180 minus 53, which is 127. And if you see A and C, their tails are also not meeting. This is given as 90 degree. So angle which we have to take still is 90 only, because we have to produce and join the tails. So in this case, theta A vector and B vector is, A vector and B vector is 143 degree. Theta B vector and C vector is, so B and C it is 127 degree, and theta A and C vector is 90 degree. Okay. So these were the important concepts which I had to discuss today, and these are the basic things of vectors that everyone should know. So now we are going to open the chat room again, and it is just like till the time there are a lot of mosquitoes, we switch on all out, good night and all, and when the work is over, we had a sound sleep or our work is done peacefully, after that we can switch off that, so that even if now mosquitoes or insects come also, they won't do any harm. So those who are sincerely listening to the class, they won't have any problem. They are listening to the class, they can later on also in their free time go and listen to the class. And those who have no interest in studies, they can do whatever they like. Okay. So now you can continue with your very important chats like how are you, where are you, these all out of the world important things. Okay. So I hope these all things are clear to everyone. Only thing I would say that have the courage or have the guts. If you are hiding online somewhere at your place and thinking that whatever we write, whatever we type, no one can do anything, have the guts when you come physically present in the class, have the guts of doing the same. And those who don't know me, if you are taking admission over here, you can come and ask your seniors, they will tell you well about me, whether I am a fool, whether I am having a bit of knowledge also of in physics or not, how I teach in the class, you will be known about everything. And those who are thinking they are too smart, they can also come and check their smartness. What you are writing or typing in the comments, unnecessary comments. So dare to come and directly tell in the class. I will be more than happy if I see that courage in you. Because if you have that courage, that means you can do anything in this world. You can achieve anything in this world what you like. So that courage should be there with you always. Understood? FF team, sir, is 0.4 I cap plus 0.6 J cap is a unit vector. Unit vector has a magnitude 1. If you have already studied vectors, then you should know how to take the magnitude. It will be under root of 0.4 square plus 0.6 square. Is it coming as 1? If it is not coming, that means it is not a unit vector. So unit vector should have a magnitude of 1. Is there any exam after the bridge course when we come to college? No. When you come to college, you will be in the group or company of other students also who due to some reasons would not have attended the bridge course. So the course will be starting commonly for all. So initially you won't be having any exam. But as I said, it will be an advantage for you since you have gone through all these points which have been covered in the bridge course. So when the things will be taught, when we already know a bit about it, or I will say that effectively if you have gone through the lectures, you would have seen lot of important things being discussed. So you will definitely feel confident that time, and if possible you may later again go through these videos or have notes of that. It will make you understand the concepts quickly and fast. So you will have an edge over other students. I can definitely guarantee that. Sir, the angle between tail and tail is always our angle between head and head. Yes, correct. Angle between tail and tail is always same as the angle between head and head. No problem about that. But remember, when we are taking the angle, that angle should be in the range of 0 to 180. You should not go for reflex angles. I hope that is clear, that confusion. Okay, and that vectors, I have just discussed the basic form. We will keep on doing things in the actual physical classes also, whichever campus you are going to. I am not aware of that, but whoever will be teaching you in whichever campus, they all will, every teacher will be discussing again the things. But as I am saying, the bridge course is actually, the word bridge itself tells that it is a pathway connecting two different places. So from 10th to 11th, what you need to know so that you can face the 11th and 12th syllabus for NEET with full confidence, that is the purpose of this bridge course. Those who did not understand many of the things, I will repeatedly be telling one thing again and again, which I say in each class. What is that? I say that these lectures that are there in YouTube, kindly go through them and listen them again. Whichever point you are feeling confusion in any lecture, you can go to the lecture previous to that. You will be clear with whatever has been taught there. Sir, will you be there in college? So here in Gosala Girls Campus, I am there, and I need not tell my name. If you know, or you would have known by now. I think in YouTube also they keep on showing the name or whatever. And if you don't know, then it's Paul Mitra. You can come over here, and also when you come, you would come to definitely know about me, who I am. Whether I am a good teacher or a bad teacher or whatever, if you want to change your perception regarding me, you want to keep the same perception, it is all up to you. My job is as a teacher who will never bear any nonsense in the class, whether it be online or offline. And I am like that. I am not going to change for anyone who is not interested in attending my lectures. If you are in my class, so I will ensure that discipline is maintained. Understood? So that will be all for today. Tomorrow's class we will be seeing further concepts of vectors. So I am very gently going with the concepts. Only the basic things we have studied today about vectors. Rest of the concepts like addition, subtraction of vectors we will be dealing in tomorrow's class. So hope that helps you all. Thank you.